All right. 13C, graphs of exponential functions. So we're trying to graph exponential function. Before we start graphing exponential function, I'll just introduce something called E. Okay, this E is same as pi. It's an irrational number, and there's infinite many decimals, and it's not circulating. Okay, so it's about 2.7. I can't remember later on, 3 or 2, next one. But it's about 2.7. Approximately is 2.7. You know pi is approximately 3.14. So it's just a number, okay? Just E, just a number. And it's called a nature number. Nature E, okay? Nature number. So this number similar to pi, irrational, infinite many decimals. We can't put that into a fraction. And we have exponential graph. What is exponential graph? Exponential graph is you have a real number base, like base is a number, and you will have the power contain some variable x or like some other variables. So it's like exponential function is the power contains variable, and base is constant. Okay, if base is a constant number, like say for example E is a constant number, and then the power is x is the variable. So e to the power of x will be the simplest form of an exponential function. So simplest form of exponential function. And if you plot that on the Cartesian plane, you have a graph similar to that. The key feature of this graph is it has well, you can't really see it clearly. It will has asymptotes at y equals to 0. There's asymptotes at y equals to 0. So you have learned this in year 10. In year 10, you have learned 2 to the power of x. Do you remember that? 2 to the power of x? Or like 3 to the power of x, you have a graph similar to that, and you will have an asymptotes at y equals to 0. And it's an increasing graph, and it also passes through the point 0, 1. Because when x equals to 0, e to the power of 0 will be 1. So it will pass through the point 0, 1, but there's no y-intercept. There's no y-intercept. Okay. And we can see this graph. We have asymptotes at y equals to 0. The domain for exponential function is always R. Okay, domain for exponential is always R. Like you can take any x. There's no restrictions on the value of x you can take. But there's restrictions on the range. So your range for this graph, okay, only for this graph is R plus, okay, above 0. Okay, not including 0, so you have R plus, all the positive real numbers. And let's have a look about the general equation of exponential. You won't really always have like 2 to the power of x, 3 to the power of x, 3 to the power of negative x. That's too easy. So that's what you learn in year 10. So in year 11, we will have a more complex form of the graph. So can you see fx here? We can express that in this form. Fx equals to a times lowercase a to the power of k bracket x minus b plus c in the end. So how many numbers I have put? You have capital A, k, b, and capital C value. The lowercase a is just a number. The lowercase a is just a number, and this is the base. It is the base. But all of these letters has an influence on the shape of the graph. What we have for A, capital A, okay, the absolute value of capital A is the dilation factor from the x-axis. So think about that, think about transformation. We stretch the graph longer if we times a number in the front, like times the 2, we stretch it longer. But if A is a half, we compress it, like shorter. And A can be negative or positive, but the factor will only be the positive. So if you have a negative, there will be some reflection happened. So I will let you know that later. And the k value will be the stretch from the y-axis. Okay, stretch from the y-axis. Stretch it that way or compress this way. B is the horizontal translation to the right or to the left. Okay, horizontal movement. And C is the vertical movement. When you sketch the graph, the B value doesn't really make a big difference. So just write down some steps. Okay, just write down some steps. What you will have. Okay, step number 1. Sketch asymptotes. Asymptotes is y equals to the capital C. The last number you add at the back will be the asymptotes. Okay, the last number you add at the back will be the asymptotes. And number 2 is think about the base shape. Okay, that is depends on the lowercase a value. The lowercase a value. Okay, there's two cases. If a is greater than 1, and the second if a is in between 0 and 1. Okay, the base shape got two different types. The base is greater than 1, say like e is a number greater than 1, 2 to the power of x is greater than 1, but like say you also have a half, a quarter, 2 or 3. Remember, a can never be negative number or equals to 0. A will never be negative number. So the definition for exponential, well, you learned that in year 10. Base can never be negative numbers. You must always have a positive number and then to a power. Why you can't have negative number is because if you have negative 2 to the power of x, let's have a think about that. You have negative 2 to the power of x. Well, when x equals to 1, y equals to negative 2. When x equals to 2, y equals to 4. When x equals to 3, y equals to negative 8. What happens to the graph? Okay, 1, negative 2 is below. Okay, 1, negative 2 is below. 2, 4 is up. 3, negative 8 is below here again. What's the shape of your graph? You can't really sketch the graph. When it meets even number, it will become a positive. When it meets odd number, it will become a negative. And also there are a lot of points which is undefined. For example, a half. Negative 2 to the power of a half equals to square root negative 2. Okay, where x equals to that. So it's undefined for that point. So it's not a continuous graph. It's not like continue like smoothly. Well, go up and down like for many points. And then a lot of points will be undefined. So this is like impossible to sketch. So we don't talk about negative base for exponential graph. So we won't have negative values. So all the a value, all the a value must be greater than 0. Okay, all the a value must be greater than 0. But like even as greater than 0, it's still classified into two groups. One group greater than 1, one group in between 0 and 1. So the basic shape we have a greater than 1 is we will have asymptotes here and it's an increasing shape. When it's in between 0 and 1, you will have asymptotes here, but it's a decreasing shape. Okay, one increasing graph, one decreasing graph. Okay, a greater than 1 increased. Y, a in between 0 and 1 decreased. But that's not your final shape. That's only the basic shape. Okay, the base shape. We have like where I start with and then apply all the transformations. That is where we start with. Okay. Why is 1 increasing, 1 decreasing? Remember 2 to the power of x looks like that. So a half to the power of x, equals to, let's say, 2 to the power of negative 1 and then to the power of x. And then that equals to 2 to the power of negative x. 2 to the power of negative x will be reflected. So if it's get reflect by the y-axis, that's why it becomes a negative graph, a decreasing graph. Okay, that's why when you have hover in between 0 to 1, base 0 to 1, you have a decreasing graph. Okay, you have a decreasing graph. Okay, let's keep going. The second step is make sure what the base graph looks like. And number 3. Okay, number 3 is look at A value. Look at A value. Well, if A is less than 0, reflect in the x-axis. Okay, you choose one of the graph above, like increasing or decreasing one, and then look at the A value. If A is negative, you reflect by the x-axis. You reflect by the x-axis. So let's say step number 3 is a red graph. If you get reflect by the x-axis, you have shape like that. You have shape like that. That will be your shape. That will be the shape. And if A is greater than 0, then remain the same. A greater than 0 remain the same. You still have those two blue graphs remain the same. And step number 4, I'll use the green one to say step number 4. Look at the K value. If K less than 0, reflect in the y-axis. Okay, reflect in the y-axis. So if this reflect in the y-axis, you have like that. If that reflect in the y-axis, that will be like that. Well, you don't need to really sketch the graph. I just show you how to get reflected. Or it can reflect twice. It can reflect twice. For example, I choose the first base shape and get reflect by the x-axis, and then get reflect by the y-axis. You have this shape. You have this green shape. And similar to that, you have this shape. If it's get reflect by the y-axis. Then you know what your graph looks like. You know where's your asymptotes. You know the trend of your graph. And therefore, I can sketch the shape of the graph and try to find any point. So number 5, find y-intercept when x equals to 0. Number 6, find x-intercept if possible. Not all the graph will have x-intercept. Not all the graph have as x-intercept. But you can see it after you roughly sketch the shape of your graph, and you can see whether there's an x-intercept or not. Okay, that's the 6th step. You will sketch for exponential graph. If you follow that, you definitely will have a correct graph. Okay? So some values you need to look at. Well, basically you're interested in the C value, that's your asymptotes. You're interested in the lowercase a value, that depends on what you start with. And the A value and K value depends on whether there's reflections happens in x-axis and y-axis. It get reflected. And then after all of that, you will try to plot the graph accurately so you find some point on this graph. Okay, I'll show you some example and it will make like a lot of sense. You just make sure you have this down, and let's go to page 2. Page 4. Let's have a look at this one. Y equals to that. So what we can see is my A value will be -1. My lowercase a value will be 3. Well, lowercase a is not -3. The negative is -1 times 3. You can say it's -1 times 3 to the power of x minus 1. And your k value must be 1. There's no coefficient, like no other coefficient in front of x, so the coefficient will be 1. And then c value, capital C, will be -1. Okay, that's what we have, and therefore let's sketch the graph. So first step, find the asymptote. Asymptote is -1. It's a horizontal asymptote. You will label that as y equals -1. Step number 1. Step number 2 is the base shape. Base shape will look at a value, lowercase a value. Lowercase a is a number greater than 1. Therefore, we have an increasing graph. This is my basic shape. Okay, we start with that increasing shape. And step number 2. Look at capital A. Capital A value is less than 1. Reflect in X. Okay, capital A is reflecting X. As I said before, it's reflecting X. Therefore, your graph become this shape now. So reflecting X here. Okay. Think about going down this way. So this shape. And number 3. K is greater than 0. A is less than 0. K is greater than 0. So your graph will still be this shape. No change. No change. Greater than 0, no change. And therefore, that's your final shape. Okay, that's your final shape. Final shape is that. So you will have a final shape like that. Can you see like that? That's your asymptote. That's your asymptote. Your graph is below the asymptote and is going downwards. Going downwards. So that is the shape. But like I need to sketch it accurately. So I will have number 4 when x equals to 0. Y equals to -3 to the power of 0 minus 1. Y equals to -1 minus 1. Y equals to -2. So I will have 0 minus 2. But is there any x-intercept? No. After before we sketch it, like the shape is like that. There's no x-intercept. So I don't need to find number 5 x-intercept. But what we need to do, like 5 is no x-intercept. No x-intercept. But like I need 2 points on the graph. Okay, remember when you sketch a graph, you need 2 points on the graph. Not 1 is not enough. I need 2. So 2 points on the graph. Well, I can just randomly select the x value and put that in. Well, you don't want to select some value like really hard to calculate. You will select 3/2, okay? So you will say x equals to 1. Well, that's the easiest way to do it. Y will be -3 to the power of 1 minus 1. Y will be -4. So you have 1 minus 4. Here is 0 minus 2. You just find another point on the graph. Just want to emphasize that again. When you sketch asymptotes, the asymptotes must be longer than the graph. Asymptotes must be longer than the graph. You cover the part of the graph. Well, you can't have asymptotes here and your graph like that. It's not making sense. Okay, so asymptotes must be beyond the graph, and the end of the graph must be parallel to the asymptotes. Get close enough to the asymptotes and parallel to the asymptote. Can't get towards to the asymptotes, can't show far away to the asymptotes. Okay, I've said that about like 3 times now. I hope you can remember it. like that's the part, like you can lose like half mark or 1 mark on the BCA exam. So make sure you sketch the graph good enough. Okay. Okay, what's the domain for this graph? What's the domain for this graph? Yeah, domain for exponential is always R unless it's like specified for you. Otherwise, there's no restrictions on the domain of an exponential graph. Unlike square root, it's naturally get a restriction on that. Unlike hyperbola or truncus, there's naturally a restriction there. But for that, no restriction. Domain is R. What is range? What bracket I should have? Both open brackets. Okay, not including 1 and infinity never like combine with square bracket. So from below until -1 is your maximum value, but not including -1. Okay, next one. Okay, for this graph. Okay, the last number is -1. The last number is -1. I will have -1 here. Asymptotes -1. So y equals to -1. Okay, let's think about number 1, base shape. A equals to 3/4. So A is in between 0 and 1, less than 1. So the base shape will be decreasing shape. It's above the asymptotes, but it's decreasing shape. Step number 2, think about A value. A equals to 1. Okay, A equals to 1. There's 1 in the front, and that is greater than 0. Doesn't change. The graph remains the same. Number 3, the K value. Okay, the coefficient for X is 1 as well. K equals to 1. That is greater than 0. Shape doesn't change, remain the same. So you have a decreasing graph. You have a decreasing graph, like a shape like that. Decreasing graph above the asymptotes. Then number 4, you need to make sure where is this graph. So find y-intercept. When x equals to 0, y will be 3/4 to the power of 0 minus 1. 3/4 to the power of 0 is 1. 1 minus 1 is 0. So it passed through the origin. Again, it has x-intercept, it has y-intercept, but unfortunately that's the same point. It passes through 0, 0. Okay, passes through 0, 0. So I need to find another point again. So, well, I can find when x equals to 1. Y will be 3/4 subtract 1. Y will be -1/4. So you have 1 -1/4. So it passed through 0, 0. 1 -1/4 is here. That's the shape of the graph. Well, need a smooth graph. Asymptotes, approaching to asymptotes, parallel to asymptotes, and get close enough to the asymptotes. Have 0, 0, 1 -1/4. That's the shape of the graph. What's the domain? What's the domain? Real. Okay, R. Range. Not including -1 to infinity. Okay. I'll give you 3 minutes to do number 3 and number 4, at least that number 3, okay? Do it by yourself, and I'll show you the answer. Okay, example 3. First, the constant was added in the front, and that's why I confused some of you. I can write y equals to -2 times 3/2 to the power of -x and plus this 2 in the end. Therefore, your capital A is -2. Lowercase a is 3/2. K value will be -5. I'm not really interested in B value. So, never really investigate on that. And you have your C equals to 2. So I will have two is my asymptotes. Okay, 2 is my asymptotes, y equals to 2. Then let's think about base shape. So base shape is like a greater than 1. I will have an increasing graph. Okay, a greater than 1, 3/2, 1.5. A definitely greater than 1. So increasing shape. Oh, today we have shortened period. Now I have 4 more minutes. Okay. Get reflected. A is less than 0. A is -1. Get reflected by the x-axis. This shape. K is less than 0 because K is -1. Reflected again by the y-axis. So still below the graph, but in this way. In this way. Okay? So my shape of the graph. Okay, below the asymptotes and it's an increasing graph. The graph must look like somehow like this. This shape. Must be this shape. When x equals to 0, y is 2 minus 2 times 3 to the power of 2 to the power of -0 is still to the power of 0. So that's 2 minus 2. Y equals to 0. So it passed through the point 0, 0. It passed through the point 0, 0. And then I need to choose another point to calculate. A lot of you has chosen 1. I don't think 1 is a good point to choose. I will choose -1. Why I choose -1? Negative of -1 will become 1 and easy to calculate. So, well, you can choose 1. There's nothing wrong. You just make like the calculation harder. When x equals to -1, y will be 2 minus 2 times 3/2 to the power of 1. Minus 1 is to the power of 1. Y will be 2 minus 3. Y will be -1. So I will have coordinates -1, -1. Okay, that's the shape of the graph. Okay, that's the shape of the graph. Oh my god, that's a bad graph. like this. You have 0, 0, minus 1, and minus 1. You will have domain of R, and you will have range of negative infinity to 2, not inclusive both ends. Okay, that's how you do this type of graph. That's how you do this type of graph. We have 3 graphs left, and I want you to do this as homework. And Thursday we will start with this first and continue with the rest.